Today we will explore right triangle trigonometry. Trig is short for trigonometry, and it is the study of the sides and angles in a triangle. Notice that we have 3 sides and we have 3 angles. We're only going to examine right triangles for today, but notice that trigonometry is not exclusive to right triangles. It includes the study of all triangles. So, I also want to draw your attention to this little box here. These are Greek alphabet, and they're Greek letters, alpha, beta, and theta. And we use these lowercase letters as variables for angles. Okay, so maybe we'll call this alpha, and maybe we'll call this one beta. We usually don't name the right angle because it's just 90 and it's very stationary. Notice that in a right triangle, alpha and beta will always be less than 90 degrees because alpha and beta add up to 90. And that's going to be a key point as we continue further in this chapter. I want to make sure you understand the concept of opposite and adjacent. The hypotenuse is always the longest side, and it's always across from the right angle. The opposite depends on which angle you're referring to. So let's say we're referring to alpha. Okay, if we're referring to this angle, then opposite of alpha is this side, and adjacent to alpha is this side. So let's not even look at beta. Looking at alpha, remember adjacent means you're touching. So for both of these acute angles, the adjacent side and the hypotenuse side are the 2 sides of the angle. Okay, the side that does not touch is the opposite. Let's look at an example to see if we understand the concept. Label each side as opposite, adjacent, or hypotenuse. So if we look at this triangle and we look at theta, from theta, A is still the hypotenuse, okay? Whatever's opposite the 90, whatever's the longest side is the hypotenuse. Now, B does not touch the angle, so that would be considered opposite of theta. And C actually touches, it makes one of the sides. So it is adjacent to theta, okay? Now, let's talk about sine, cosine, and tangent. These are 3 ratios that compare 2 of the 3 sides of a right triangle. So, for sine, and notice I put theta because the ratio only makes sense if you know which angle you're referring to. So if we go, if I ask you the sine of theta, that means I want you to compare the side opposite over the hypotenuse. Cosine, I'm asking you to compare the adjacent over the hypotenuse. And for tangent, that's opposite over adjacent. Hopefully you see this so katoa, so as in so what, ka as in get out the car, and toa, I toa to do what I said. Okay, so katoa is a good way to remember your trig ratios. The S is for sine, C is for cosine, and T is for tangent. The O stands for opposite. The H is for hypotenuse. And the A is for adjacent. So if you forget these ratios, you can just say, oh, tangent, that's OA. So that means opposite over adjacent. You see that ratio right there. For example 2, I'd like for you to look at this triangle and figure out what two sides represent the sine of alpha. That means you go to the angle labeled alpha. You ask yourself, what does sine represent? It represents opposite over hypotenuse. So I go to alpha and I go opposite is B and hypotenuse is A. So for this triangle, the sine of alpha is B over A. For cosine, that means I want adjacent over hypotenuse. See, cosine is adjacent over hypotenuse. So I go to alpha, the adjacent side is C, and the hypotenuse is still A. For tangent, tangent is opposite over adjacent. So I go to alpha, the opposite is B, and the adjacent touching is C. A shortcut that you can always remember, and it'll always work if you put it in this order, sine, cosine, tangent, you can always look at the numerator of sine over cosine, and that'll give you the tangent. And that's a nice little shortcut. Example 3. Without a calculator, find the exact values of sine 60, cosine 60, and tangent 60. And you might say, without a calculator, how can I possibly do that? Well, all you have to do is draw any 30, 60, 90 triangle. We just want a right triangle with a 60-degree angle. So if I draw this one, let me do a little bit better job on drawing that 30, 60, 90 triangle. So let's say this is my 60 and this is my 30. Now I can simply go to this 60-degree angle and do opposite over hypotenuse. But there's no numbers, there's no letters. However, we do know the relationships of these sides. And in our last lesson, we did learn some 30, 60, 90 triangles. So here's one thing I can do is I can say, well, what if this side were 5? Remember, we multiply by 2 and the hypotenuse is 10. Multiply by radical 3 and the long leg is radical 3. So I could simply go here and say opposite over hypotenuse, 5 radical 3 over 10. And then I could reduce it, and I'd get the square root of 3 over 2. And that would be the answer for the sine of 60 degrees. But I also want you to notice that I could have made these any values. I could have said, well, let's make this side 10,000. Then this one would be 20,000. And this one would be 10,000 radical 3. And if I were to do this again, opposite of the 60, would be 10,000 radical 3 over the hypotenuse, which would be 20,000. And notice that I would still get radical 3 over 2. So the ratios will be consistent regardless of the triangles that you select. So for me, my favorite triangle to choose is the one where I won't have to reduce. So the one I like is let the short leg be 1. Let the hypotenuse be 2. And let this one be radical 3. That way, opposite, that's radical 3 over hypotenuse is 2. You don't even have to reduce. This is my favorite 30, 60, 90 triangle. Let's do the cosine of 60. The cosine ratio is adjacent over hypotenuse. So if I go to 60, adjacent is 1, hypotenuse is 2. So my exact value is 1/2. Now if I want to know the tangent of 60 degrees, I have to go opposite of the 60 over adjacent. That's what SOHCAHTOA says. So the opposite is the square root of 3. The adjacent is 1. So the square root of 3 is the exact value for the tangent of 60 degrees. Again, doesn't matter what triangle you use, but I like this one just so I don't have to reduce. Example 4. Without a calculator, find the exact values of sine 45, cosine 45, and tangent of 45. Now, in order to not use a calculator, we're going to need some version of a 30, 60, 90 or 45, 45, 90. So these are the triangles that we would have to deal with. I guess I should have put hyphens in there if we want exact values. Otherwise, we'll probably need a calculator. Okay, so I'm going to show you how to do this one. So for a 45, 45, 90 triangle, I can choose 6, 6, 6 radical 2, because remember you just multiply the leg by radical 2. But then I would have to reduce, so of course I simply would choose something that I'm not going to have to reduce, which would be 1, 1, and 1 radical 2. So here, I'm going to go to either of the 45-degree angles, and I'm going to go opposite over hypotenuse. So from the 45, opposite would be 1. Hypotenuse would be radical 2. Remember, we want to rationalize. So I get the square root of 2 over 2. Final answer for that. Now for the cosine, that's adjacent over hypotenuse. So that would be 1 over the square root of 2. So we get the same exact value because those legs are the same. The opposite and the adjacent have the same value. Alrighty, let's look at the tangent of 45. Tangent is opposite over adjacent. So opposite, adjacent. That's just 1 over 1, which is 1. Example 4. With a calculator, go ahead, pause the video, and grab your calculator. We're going to make sure you know how to punch in these values. You don't want to wait until you're taking a quiz or a test to discover you don't know how to punch it in. So we want to make sure. And I'm asking you to round to the nearest thousandth. So tangent of 15 degrees. So you do want to make sure your calculator is in degrees, not radians. I'll teach you about radians next lesson, or maybe the one after that. So you want to make sure your calculator is in degrees, and it usually starts in degrees. So to the nearest thousandth, and because I'm rounding 3 decimal places, I like the leading 0 before the decimal, just to make sure I don't overlook the decimal. So I'm seeing 2, 6, 7, 9. So 6, and the 7's going to round up to an 8. Because on the calculator, this is what I saw. So nearest thousandth, the next digit is over 5, so I round up to 8. Now the next one is the sine of 120 degrees. And we have 866. Cosine of 330. Oh my goodness, will you look there? And we will talk soon. How is that possibly the same value? Well, that's very possible, and we'll talk about why that can happen. Sine of 227 degrees. Oh my goodness, Miss Adams, it's negative. Is this a mistake? Nope. We're going to talk about what that negative means. And we'll have to understand the context of the negative side. Because you might say there's no way to have a negative side of a triangle. And you're exactly right. But we're going to be looking at obtuse triangles. We're going to be looking at all types of stuff. So it's going to get really interesting. And we'll use the negative sign to denote direction. And that's a concept that you'll get accustomed to using. The next time, we're going to talk about the other 3 trig ratios. Today, we only learned about 2 trig ratios. So we'll learn about the other 3. Okay? And for a moment, I'd like to make sure you know why they're necessary, or why even say we have 3 more. If you take a triangle, it has 3 sides. The trig ratios only compare 2 out of the 3. So if you think of what are all the ways I can pick 2. You could put A over B, or you could put B over A. You could do A over C, or you could do C over A. You could do C over B, or B over C. So that's 1, 2, 3, 4, 5, 6 different ways you can compare 2 sides. Okay? A over B, we already know, depending on the angle, let's say it was here, that'd be opposite over hypotenuse. So this might be the sine. But now we're going to have some other trig ratios that you're going to learn in the next lesson.